can go through the proof with f prime being the difference, the limit of the difference quotient, but I'm going to give you the result. So sine prime is cosine x, and cosine prime is negative sine x. And now we can determine the derivative of any other. So the derivative of tangent x, cotangent x, secant x, and cosecant x. So let's determine one, any of these, and then I will give you the rest. Which one would you like to prove?
Tangent.
Tangent, very good. The tangent is a very good one. Tangent x. Does anyone remember what does tangent x equal to?
Cosine x over sine x.
The other one. So it's sine x over cosine x. Good. So this is what? Which rule will I apply to determine tangent prime? Yes, of course. Can anyone help? I'll help with the easy one.
Would be cos x
Sine.
minus sine x times or cos x
Careful.
minus sine x.
Good. So sine prime is cosine times the denominator minus sine times the denominator prime, which is negative sine. Good. Let's see what we get. Cosine squared, but plus sine squared. Does anyone remember how much this is?
One.
Very good. Awesome. So over cosine squared. And remember, 1 over cosine is secant, so this will be secant squared. So one more time, let's write all of them here. Sine prime is cosine. Cosine prime is negative sine. Tangent we already discovered is secant squared. Cotangent is negative cosecant squared. Secant equals secant tangent, and of course cosecant will be negative cosecant cotangent. So these have to be memorized. These are the basic rules. Okay, so let's go back and choose anything you want.
Oh my gosh.
Yes? Any questions?
Sorry.
That's okay. I can go back.
17.
It's a good one. Let's try 17. Good pick. Let's copy it and then, okay, f of x, I'm going to write f of x, sorry. 1 plus secant x over 1 minus secant x. And when you go back, you can just replace x with w. It's easier for me to write and easier for you to see. Okay, so which rule are we going to apply in order to differentiate this function?
We do the quotient rule.
Excellent. 1 minus secant x squared. Very good, awesome. So let's differentiate the top. What is the derivative of 1?
Zero.
Perfect. So secant prime, we just learned that, is secant times tangent times the denominator minus, I copy the top, but now I have to differentiate the denominator. 1 prime is 0, minus is minus, and when I differentiate secant, I get secant tangent.
Would it still be negative if the
Because there is a negative here, I have to copy it. Is this okay?
yeah.
Okay, perfect. So now, do not try to simplify anything with the denominator. Please don't ever attempt this. Okay. So I copy 1 minus secant squared. Let's see what if I can get rid of anything from the top. Secant tangent times 1. Secant tangent times secant minus secant squared tangent x. So secant tangent times 1, secant tangent times secant with minus in front. Now, negative secant tangent with 1, but with minus in front. So this is positive secant tangent. Now, negative secant tangent times secant, it will be negative secant squared tangent with minus in front, plus secant squared tangent x. Yes, so something is going away. And now secant tangent plus secant tangent, 1 apple plus 1 apple, 2 apples. Secant x tangent x over 1 minus secant x squared. And this is it. Now, I would like to talk, because we have what we need, and I don't want to wait till chapter 4. I'd like to talk about a theorem, or a rule if you want. It's called L'Hopital's rule, because of what follows next. It will make our life much easier. This is in chapter 4. But it will make our life so much easier once we understand it. What did this mathematician show? He showed this, that if I have a limit as x approaches a number from a ratio, let's say one polynomial at the top, from a rational function, one polynomial at the top and one polynomial at the denominator, and the initial estimation is 0 over 0 or infinity over infinity. So a lot of things have to happen. Limit, ratio, 0 over 0 or infinity over infinity. Then limit as x approaches a from p of x over q of x can be determined as limit as x approaches a from p prime over q prime. Do not ever do this in a ratio. No. This is allowed only in a limit, inside a limit. So if I have a limit applied to a ratio, if this is the case, I cannot do that. So the limit and the ratio have to be together, and not 5 over 0 or 2 over 2 or 10 over 10 or 5 over 15. No, only in these two situations, not in infinity minus infinity or any other indeterminate case. Remember, we said there were 7. So limit, ratio, 0 over 0 or infinity over infinity, I'm allowed to do this. So what am I doing with this? In a moment, I'm going to explain. We want to talk about something very important. The limit as x approaches 0 from sine x over x. Or it can also be flipped. Limit as x approaches 0 from x over sine x. Okay. So the preliminary situation, we have to find out what it is. So what is the case here when x approaches 0? What do we get? So we have a limit, we have a ratio. So what is the first assessment, if you want? Yes, and what do we get? Very good.
One.
Which one? Where does the numerator go?
Zero.
Good. Where does the denominator go?
Zero.
0. And I hope you did not conclude that 0 over 0 is 1, right? Good. So all conditions are fulfilled. We have a limit, we have a ratio, and we have one of the two situations allowed. Good. So then I copy limit as x approaches 0. Can anyone give us the derivative of the top?
Cosine x.
Excellent, very good. Can anyone give us a derivative of the denominator?
1.
Good. So now let's find the answer.
Is it 1?
Exactly. But I just wanted to make sure that no one thought that 0 over 0 was 1. So indeed, the limit is 1. In the same way, this is also 1. But what is important here is to understand something else. That the limit of anything approaching 0 from sine of the exact same thing over the exact same thing, all these are identical. What is the answer?
Is 1.
Exactly. So this is extremely important to remember. If these are not the same, for example, let's say I have here, I'm not going to change that. Let's say I have this. X approaches 2 from sine x minus 3 over x plus 1. So remember, we can subtract 2 from both sides. If x approaches 2, x minus 2 approaches 0. But I don't have x minus 2 here, and I don't have x minus 2 here. So this situation does not fit our function and our limit when this and this and this are all the same. So I cannot say 1. Whatever it is, maybe the limit may exist or not, but I cannot use this concept because these three are not identical. So I'm going to share. So let's practice this. Please remember, you're not going to get away from limits at any point in time. So here they are. So let's look at any of these. So let's choose.
I'm going to choose 50.
Okay, very good. Let's start with 50. Where is it? I see it. Good. So in 50, so we have limit as x approaches 0 from 1 minus secant x over 2x. Good. Then I would like to look at a limit like I will choose, let me write this on the side, like 60. So limit Moving forward, you are allowed to use L'Hopital's rule whenever it's applicable. Okay, perfect. Good. So we're asked to find this limit. The first step is we have to identify what it is. Can anyone tell us what it is? Where does the numerator go? Where does the denominator go?
Zero and zero.
Exactly. So all conditions for L'Hopital's rule are fulfilled. The limit is there. This is a ratio. It's one of the allowed indeterminate cases, 0 over 0 or infinity over infinity. I can go ahead and differentiate the top by itself. Remember, we never do this. This is a function that is a ratio. But limit, ratio, 0 over 0, I'm allowed to differentiate the top and differentiate the denominator. Let's differentiate the denominator first. What do we get?
2.
Very good. What do we get at the top? So 1 is 0, but negative has to stay. And the secant prime is secant tangent. Good. So now, where does this go when x approaches 0?
Zero.
Very good. Where does this go when x approaches 0?
One.
Yes, secant is 1 over cosine. Yes. So how much is negative 1 times 0?
0.
0 divided by 2. I have $0 and I choose two of you to share my 0 with. I'll divide my 0. What will you get?
0.
0. Very good.